I'm Yan. I'm a PhD student from Leiden Observatory working with Joe Hanawi. And today I'm not really going to talk about any JWST results, but some results from JWST new neighbors at L2 Point, the Euclid telescope. And the topic is hunting high-Z quasars in the Euclid era. The quasars we're chasing after are those rarest monsters in the universe, those at the very bright end of the UV luminosity functions. And the number density of this kind of quasars are just too low, and we can only uncover them with the largest imaging surveys. So many optical and infrared surveys have been used to hunt for this kind of objects, but all reach their limits in terms of the survey area, the survey depths, and also the wavelength coverage. But now we have Euclid, and here I'm comparing Euclid with two other infrared surveys used before. And you can see there are differences in depths and also differences in the sky coverage. So, okay, thank you. Okay, so right now with Euclid, and here's a comparison, and you can see that Euclid is going to be the best tool to hunt for high-redshift quasars for us in the coming decade. The classic method to select quasar candidates is color cuts, but the success rate of color cuts dropped significantly at redshift larger than 7. That's why we opt to choose the probabilistic approach. And the idea of probabilistic approach is quite straightforward. Basically, we just model the quasar density and the density for the contaminant, and with some additional priors, we can compute the probability of an object being quasar given its colors. Our own probabilistic method is different from others in two different aspects. The first aspect is in terms of quasar density model. We use a new quasar density model based on a new generative model for quasar spectra we newly developed. The reason for this new model is that it includes, we want a model that includes a variation of the entire population. And to achieve this purpose, we start with a large sample, spectroscopic sample at lower Z, which is mainly from Sloan, and also a large compilation of near R spectra, which I'm showing at the upper left. And with this, we build a PCA, we train a PCA-based generative model. And on the right-hand side, you can see the density models of quasars as a function of different redshift. With this density model, we can also build a photo Z estimator, and in the middle, I'm showing an early result, which works as we expect. Another different aspect of our model is the contaminant model. So we do not pre-assume what kind of a contaminant we are going to see. Namely, we don't build specifically a brown dwarf model or red galaxy model. Instead, we treat everything just as a single class. We call them just contaminant. And the reason why it works is because, and this kind of contaminant model is based on all the dropout sources, or the dropout point sources themselves. And this kind of method works because the number of quasars there are just too few of quasars, and it won't affect the computation of the entire density. And right now, for the first trial, we're using just the 200 square degrees from Euclid. And on the right-hand side, you can see the fitted density models, the noise deconvolved densities of quasars in purple and contaminant in green. And here's the results of this first trial. We observed 18 candidates selected from 200 square degrees with KAG Elris in one night. And 3 of them turned out to be high-Z quasars. And we expect 4 of them based on the luminosity function. On the right-hand side, you can see the Euclid cutouts and also the KAG spectra and also our photo Z. One of them have a blooming Lyman alpha, and one of them may be a Radon BAL. Okay, so here's a summary of this first trial. We think it is a very successful first trial because here's a comparison between the previous quasar search and the new quasar search. And we are selecting quasars with a speed like at least 10 times faster, and we are seeing things much fainter, which is at the regime that can bridge the faint bright quasar and also the bright JWST selected AGN. And the last message, I think, is stay tuned because more is on the way. The survey is just the first 6 months of the entire 6-month survey, and we have only followed up 1% of the entire footprints, and we are going to see much more quasars soon in this red circles regime. Thank you.